Assalamu alaikum. How are you guys? I hope you are all in a good health. Last lesson we talked about electromagnetic waves, and we said all electromagnetic waves have the same speed, including light, which was a type of electromagnetic wave. In this part we are going to concentrate on light. What about the properties of light and its interaction with matter? You can see here it says light is the energy emitted from bright object causes visibility. So as a result of light we can see our surrounding. Let's get to some properties of light. First of them, it's Higgins principle. Higgins principle shows us light can interact with matter, for example air. So air particle has a great effect in spreading light. If there wasn't that interaction between air particles and light wouldn't be spreaded in all directions. Instead it will be just a ray like a laser, and it would not be spreaded in all directions. So Higgins principle says all the points on the wavefront of a plane wave can be treated as a point source that's coming from the source. To understand this, we have to look at this figure. Here we have a source of light. This source of light emits groups of waves. So here this is the first group of wave, the second group of wave, and the third group of wave. This is the first group of wave, which is the oldest wave, first emitted light. It's called as wavefront. This part is called as wavefront. And Higgins says every part in the wavefront which interacts with air could be counted as a source of light. So we can say this is a source of light, emitting light. The first group of wave that's emitted from the source is called as wavefront, and this wavefront could be counted as a source of emitting light. But this source the light from this source, if you count it as a source of light, will not be very intense or very strong light, because it will be scattered by air particles. To understand this phenomena, we have to look at this figure here. Here we have the source of light, waves that's coming from the source of light. This source of light is passing through a small slit. Let's say this is an air particle. So if a wave passes through an air particle, it will be scattered, and as a result of this scatter, this air particle could be counted as a new source of light. This is the Higgins principle. So if we don't count this part, we can say this is a new source of light that produces wave of light. To demonstrate this phenomena more, if you say we have more than one air particle for scattering the light, for example in here you can see more air particles here, and the light waves pass through them. There are more scattering here, and we can see light is spreaded in all directions. So every point here, as we can see, we can say they are new source of light, because they are changing the direction of light continuously. They are changing the direction of light. That's why we will say they are new source of light. Now here we have a figure. The figure says according to Higgins principle, a wavefront can be divided into point sources. A line tangent to the wavelength from these sources make the wavefront's new position. Here we have tangent line, here we have the wavefronts. We have a question here. It says, what's the benefit of Higgins principle? The benefit is to know the properties of wave that interacts with matter. The definition of wavefront It says it's the area of surface which all wave points of a wave vibrate together in the same phase. What's the meaning of same phase? This is important. It means if you have two waves, and those waves, they will rise together and lower together. That's why they are called as same phase. Now that was the first property of light, which was